Welcome back, everyone. Let's jump right into today's explainer. As we continue our official training for the PyLadies Rivers community, we're going to tackle a concept that, honestly, trips up so many new developers. We're solving a huge mystery today. How exactly does Python know which variable you're talking about? You know, when you start writing bigger programs, you're going to have variables everywhere. Understanding how Python keeps them all organized is the ultimate secret to writing clean, bug-free code. So picture this. Imagine you have a variable named name tucked inside of a function, and another variable also called name just sitting outside of it. Which one is Python actually going to use? Will they override each other and cause chaos? Well, we're going to learn exactly how Python makes that decision behind the scenes, completely avoiding a program crash. Here is our quick roadmap for today's explainer. 1. Understanding variable scope. 2. Local versus global variables. 3. Shadowing and modifying variables. 4. The famous LEGB search rule. And 5. Best practices and summary.
All right, kicking things off with Section 1, Understanding Variable Scope.
The absolute most crucial thing to remember here is that scope is, at its core, a boundary. It strictly determines where a variable is visible and where it's usable. If you try to use a variable outside its designated scope, Python simply won't know it exists. And honestly, it's a good thing. Without scope, any random function could accidentally change variables from anywhere else in your program. It would literally be total chaos.
A great way to think about this is by picturing a bustling office building. Some variables are like an employee locked away in a highly secure department. Only their direct team can ask them for information. Other variables, though, are like the front desk receptionist. They're right out in the open, available to your whole program, and ready to assist anyone who walks in the building.
Moving right along to Section 2, Local versus Global Variables.
Let's ground this with a real-world scenario. Think of a local variable like a teacher's classroom attendance sheet. It's on a piece of paper that stays inside that one specific classroom. Only the teacher and the students in that exact room can see it. On the flip side, a global variable is like the school's name. Let's say PyLadies Rivers. It's painted in huge letters on the front of the building, meaning everyone in the entire program knows it.
Breaking down the core differences side by side really clears this up. Notice where they're created. Local variables are born inside a function, while globals are created outside. But the real game changer here is the lifespan. Local variables are strictly temporary. The very second their specific function finishes running, poof, they disappear entirely. Global variables, however, stick around until your entire program finishes running.
Okay, let's see this in actual Python code. We define a function called greet, and right inside it we create a local variable called name and set it to Ada. Calling the function prints Ada perfectly. But if we step outside the function and try to print name, Python literally crashes and throws a name error. It's basically throwing its hands up saying, I have no idea what you're talking about. Why? Because outside that specific function, Python has never heard of it. The attendance sheet never left the classroom.
Let's dive into Section 3, Shadowing and Modifying Variables.
Now this is where it gets super interesting. What happens when the names overlap? We have a global variable name set to Grace, but inside our greeting function, we create a local variable that is also called name set to Ada. When we call the function, it prints Ada. You see, Python will always look for the nearest scope first. That means our local variable temporarily shadows, or hides, the global variable while we're inside the function. Once the function ends and we print name globally again, Grace is still right there, completely untouched.
But wait, you might be wondering at this point, if they're so separate, can my function actually reach out and permanently change a global variable? Like, what if you need to update a score in a game or change a bank balance?
Well, if you just try to add to it directly, say you have a global count of 10, and inside a function you write count equals count plus 1, boom, Python hits you with an unbound local error. This is such a classic beginner trap. Python sees you putting count on the left side of an equal sign, so it assumes you're trying to create a brand new local variable. But then it tries to read the value on the right side before it's even been created, and it just crashes.
The fix? It's the global keyword. By typing global count inside the function, you're explicitly giving Python an instruction. Hey, do not create a new local variable here. I want to use the global one that already exists outside. Once you do that, count plus 1 works flawlessly, and our global count becomes 11. Now, a quick heads up. We'll see in just a moment why you probably shouldn't overuse this little trick.
Which brings us to Section 4, the LEGB search rule.
Finding a variable in Python is exactly like looking for your misplaced phone in real life. You search in a very logical order, right? First, you check the closest possible place, your pocket. If it's not there, you expand your search to your bag. Still nothing? You check your room. Finally, as a total last resort, you go ask everyone in the house. Python searches for variables in that exact same progressive way, starting from the closest place and moving progressively outwards. And that brings us to the famous LEGB acronym. This is Python's strict search order. First up, L for local, inside the current function, that's your pocket. Next, E for enclosing. This applies if you have a function inside another function, that's your bag. Then G for global, the file level or your room. And finally, B for built-in, Python's preloaded tools like print or len, the whole house. If Python checks all 4 levels and still can't find your variable, that is when you get an error.
Let's put LEGB to work in a practical scenario, like calculating a shopping bill with VAT. We have a global VAT rate of 0.075 sitting at the top. Inside our calculate total function, we pass in a price. When Python hits the math equation, it first looks for price locally, found it immediately. Then it looks for VAT rate. It checks the local scope, not there. It checks enclosing, nope. It checks global, boom, found it. It uses both values to calculate the total locally, giving us the exact right price without a single error.
Finally, we've arrived at Section 5, Best Practices and our summary.
Listen, avoiding these common beginner traps will literally save you hours of pulling your hair out debugging. We've talked about them. Don't try to print local variables outside their functions. Don't forget the global keyword if you absolutely must change a global variable. And please, whatever you do, don't fall into the trap of putting all your variables at the top of your file just to avoid dealing with scope. That completely defeats the purpose of using functions to organize your code.
So what should we do instead? Rather than reaching for that global keyword, a much better approach is to pass information into your functions using parameters and then simply return the updated values. Try to keep your variables local whenever you possibly can. It makes your code so much easier to read, easier to test, and it guarantees that one part of your program won't accidentally break another part.
Understanding scope and the LEGB rule gives you total, absolute control over how data flows through your Python code. So I want to leave you with this. When you sit down to tackle this week's PyLadies Rivers assignment, how are you going to structure your project to keep your variables perfectly organized? Think about those boundaries, keep your data safe, and as always, happy coding.